Do you want to learn how to make an Arduino Omega based HMI system using 7-inch TFT LCD touchscreen? Then watch this tutorial from start to the very end. Because in this episode we will be controlling multiple loads using relays, and we will also be monitoring a sensor. This project is entirely based on my previous two tutorials. In first tutorial we created one button to control an LED and display the on time of a controller in seconds. In this tutorial we covered all the basic functions. While in second tutorial we converted two images and then displayed those images on the LCD. In today's episode we will combine the techniques used in the previous two tutorials. The sensor values, as you can see on the screen, are actually the images which I converted. In my previous tutorial I explained the image conversion in very detail, so I suggest before watching this tutorial, first watch the previous two tutorials, otherwise you won't understand. So let's get started. These are the two wires which I solder with ground and pin 13 of the Mega for controlling an LED. As in today's episode I will be controlling 4 relays, so it means I will have to solder 3 more wires with pin number 12, 11 and 10. I will also solder one wire with 5 volts and another wire with a 0 pin of the Mega. So as you can see, I soldered wires with pin 12, 11, 10, 5 volts and ground of the board. First connect the ground wire of the relay module. Now connect the ground wire of the board. Now connect the 5-volt wire of the Mega. Now connect the ground wire of the variable resistor with the grounds coming from the relay module and Mega board. Now connect the red wire of the variable resistor with the 5-volt wire. Now insert the white wire into the breadboard. This wire is soldered with analog pin A0 of the Mega. Now connect the middle wire of the variable resistor with the wire that is coming from a 0 pin of the board. We will be using this variable resistor as a sensor. If you want, you can connect any other sensor. And now connect the 4 wires soldered with pin 13, 12, 11 and 12 with the relays. So now the interfacing is done. The interfacing is very simple. Variable resistor is connected with analog pin A0 of the Mega, and the relays are connected with pin 13, 12, 11 and 12. Leftmost and rightmost pins of the variable resistors are connected with 5 volts and ground. Relay module ground is connected with the ground of Mega. Now let's start the programming. Once again, I want to tell you, if you didn't watch my previous two tutorials, then stop over here, first watch those tutorials and then you can resume from here. As you can see, it's a very long program, but trust me, it's really easy. And I'm not going to explain each and every instruction because all of the functions used in this program I've already explained it in my previous two tutorials. So first of all, we start with the header files, which I explained in very detail along with the documentation consisting of the basic functions. And then some fonts which will be used. We have small fonts, big fonts and 7-segment style fonts. As we will be controlling 4 relays, so for that we will be needing 4 flags for monitoring the status of the relays, whether they are on or off. It also stops the unnecessary repetition of code. If you want to learn in detail how to use flags in programming, then watch my tutorial. Integer button 1 on is equal to 0. This will be used as a flag for button 1. Integer button 2 on is equal to 0. This will be used as a flag for button 2, and so on. Integer alert 1 is equal to 0. This will be used as a flag for monitoring whether the sensor value has exceeded a certain threshold value or not. So with the help of this flag, we will be printing an alert message on the right side of the LCD. This alert message can be normal or exceeded. Integer relay 1 equals 13. Relay 1 is connected with pin 13. Integer relay 2 is equal to 12. Relay 2 is connected with pin 12, and so on. So integer relay 3 is equal to 11 and integer relay 4 is equal to 10. Integer sensor 1 is equal to A0. Sensor connected with A0 of the Mega. We will be using a variable register as a sensor. Integer XY. These two variables will be used for storing the X and Y coordinates values. These instructions are not used. Then these are some colors which I already explained in my previous tutorial. UTFT MyGLCD TDB50. Then we have pins 38, 39, 40 and 41. Remember to change the model parameter to suit your display module. UTouch MyTouch, which is a function, and it takes arguments 6, 5, 4, 3, 2, which are the pin numbers, as the input. These are the images converted into arrays. Let me show you the images which I converted. As you can see, these are simple images of the type JPG with black background. Then using a software, I converted these images into the files with C extension, as I explained this in very detail in my second tutorial, in which I displayed 2 images on the LCD. This one is for the electronic clinic banner. Integer scale is equal to 3 for the pic size to make it larger or smaller. For specifying the upper left X coordinates and Y coordinates for digits, as the digits will be displayed in the same row, so the X values will be different and the Y values will be the same. So integer image X is equal to 100 for digit 1. 100 is the X coordinate of the upper left corner. Integer image Y is equal to 200 for digit 1. 200 is the Y coordinate of the upper left corner, and similarly for the others. XY coordinates and scale for electronic clinic banner. Now the XY coordinates for button 1. So you can see these are the coordinates of the button, and similarly the XY coordinates for the button 2. XY coordinates for the button 3. These are simply the X and Y values, and the XY coordinates for button 4. The Y1 and Y2 values for all the buttons are same, as all the buttons will be displayed in a row. Finally, we set up UTFT underscore buttons, so Y drop buttons. This is a user-defined function whose return type is wide. Means that this function is not returning any value, and the empty parentheses means that this function is not taking any argument as the input. Draw the upper row of buttons. MyGLCD.setColor for setting the color. So this function is used for setting the color, and this is the filled round rectangle. Draw a filled rectangle with slightly rounded corners at the specified coordinates. And then this is a function to use to set the color, and then we draw another rectangle, and then myglcd.print and print on the button at coordinates 50 and 40, and then sets the back color. Then the same programming is repeated for the other 3 buttons. So this is the button number 2. So as you can see, the only difference is in the button names and then button 3 coding, and then button 4 coding. Then we write device 1, device 2, device 3 and device 4 with all the 4 buttons. As you can see, the coordinates are defined. So for device 1 the coordinates are 10 and 100. For device 2 the coordinates are 160 and 100. For device 3 310 and 100, and for the device 4 470 and 100. For line, I'm actually using a rectangle for creating a thick line and set the color my GLCD dot draw rectangle. So these are the X and Y values 10, 120, 610 and 124. Then there's a white color and then a fill rectangle. So we are only repeating the function. So for a large rectangle we have these coordinates and the colors, and for right side rectangle for alerts display. So as you can see, we are just repeating the instruction. Then there is a draw rectangle, then we set the color, then we fill the rectangle, and then we print the alerts at coordinates 620 and 20. Now for displaying the digit pictures, my GLCD.draw bitmap, which is a function, and it's taking some arguments as the input, the image X and image Y. So these are the X and Y coordinates of the upper left corner of the image, and 50 is the width and 38 is the height, and this is A0 scale. So as you can see in these instructions, we are using same A0, A0 and A0, and as you can see the width and height of all these images are exactly the same, but the only difference is in the X and Y coordinate values. So by default we are displaying 0, 0, 0. For electronic clinic banner, my GLCD.draw bitmap electronics X and electronic Y 235. These are the width and height, and then the electronic this is the name of the array, and then the scale which we already defined. Then there is a white setup function, serial.begin 9600. Turn on the serial communication if in case you want to send data to the serial monitor as well. So as relay is an output device, so that's why set it to the output using a pin mode function. So we set all the relays as output, and then we keep all the relays off by default. So that's why we are using a digital write relay 1 low, and similarly for the other 3 relays. Then pin mode sensor 1 input, as we know that sensor is an input device. So initial setup, then my GLCD.init LCD. So as you can see, the parentheses are empty, so it means that by default the orientation will be set to the landscape. Then there is a clear screen function. Then we initialize the touch, and then we set the precision, and at this time we are using the precision which is medium. Sets the precision to medium, while other types of precisions are explained in my first tutorial. And then we set the fonts, then we set the bake color, and then we call the draw buttons function. Now starts a while loop function while true. If my touch.data available, if the screen is touched, then read it, and x is equal to my touch.getX, store the x coordinate value and x variable, y is equal to my touch.getY function, store the y coordinate value and y variable. Now we check each and every button using an if condition. For button number 1, if x is greater than button 1 x1 and x is less than or equal to button 1 x2, and y is greater than or equal to button 1 y1, and y is less than or equal to button 1 y2, and button 1 on is equal to 0. The button 1 on is actually the flag which we set to 0 in the start of the program. So if this condition is satisfied, then the wait for it function is called. Then we set the color, then we fill the round rectangle, and then we set the color, then draw a round rectangle, and then we print off on the button at coordinates of 50 and 40. Then again we set the bake color, and then if you want to send the on message to the serial monitor, then we use this instruction, and then digital write relay 1 high turns on relay number 1. Button 1 on is equal to 1, change the flag from 0 to 1 and make x and y variables equals to 0. Delay 1000 millisecond, then a delay of 1 second. Now again we check the same button if it is touched, and if this time the flag is changed, you can see we changed it from 0 to 1. So if this time a button is changed, it will turn off the relay. So we just simply copied this code and pasted over here, and we made few changes, like instead of the off we wrote on the button. Over there you can see there is off, and over here it's on at the same coordinates 50 and 40, and then again the same instructions, and then we digital write relay 1 low, turns off relay number 1, and button 1 on is equal to 0, change the flag status back to 0 and make x y variables 0. Then there is the same delay 1000, which is equal to 1 second. Now similarly for all the remaining 3 buttons, the only difference is in the button numbers and the relay numbers. Now we define 5 variables of the type integer sensor data D1, D2 and D3. Sensor is equal to analog read sensor 1. Read the sensor, which is a variable register, and store the value and the variable sensor. My GLCD dot set bake color, then we set the color for white color, and if the sensor data is greater than 600, then write exceeded in the alert window at the specified coordinates 640 and 100. Then we print the sensor 1 at coordinates 620 and 80, and my GLCD dot print exceeded at coordinates of 640 and 100. Alert 1 is equal to 0 and make the alert flag 0 to stop the unnecessary repetition. If sensor is less than 600, so if the sensor value is less than 600, then write normal in the alert window and make alert flag 1 to stop the unnecessary repetition of code, and then same coordinates are used, which are 620 and 80 and 640 and 100. Now the purpose of these instructions is to separately access all the 3 digits. Data is equal to sensor divided by 10, and then D3 is equal to sensor percent 10, and then D2 is equal to data percent 10 digit 2, and this and then D1 is equal to data divided by 10 for digit number 1. Now we'll be using the if condition to check each digit and then display the image of that digit. For third digit, if D3 is equal to 0, my GLCD dot draw bitmap image x3 image y3 50 38 A0 in scale. So if that is 0, then we will display the A0 image, and as you can see the width and height of all the digits are exactly the same. The scale is same, and as you can see the x coordinates and y coordinates are same for the third digit. And now for the second digit, the x coordinates and y coordinates are changed, while the width and height remains the same. And then again the scale is same, and then now for the first digit, the only difference is the image x and image y values are changed, and while the width and height remains the same, and the scale is also same. Then there is a wide wait for function. We are setting some colors and myTouch.data available function, and list all the files in the card with date inside, so which is also set color and draw a round rectangle So now we'll upload this program into the controller, and I will show you this project in action. I hope you liked today's episode. Like and share this video with your friends. See you in next episode, and thanks for watching.